We're down to the very last question in the worksheet we've been working on here. This is the worksheet that starts way at the beginning as slope and lines, and as you move on down, the questions that you probably were assigned today were questions 8, 9, and 10, which we've done before, 11, which we just finished up, and now question 12 is the very last one. And question 12, you'll see, maybe it looks like it's new, and there's a few ways you could solve it, but I'm going to show you a way that I want you to be sure to understand, because this is a method that will work without even graphing it. Like, I've had some people ask me about this one and say, well, couldn't I just solve it through graphing it? Yes, you could, but you don't need to graph it. You could say to yourself, if I have 2 points, you may remember from before, as long as you have 2 points, you can get a rate of change between those 2 points. You're going to need your regular rate of change formula, y2 minus y1 over x2 minus x1. Right? That's your rate of change formula. I'm going to put a little line through it so we see that it's a fraction. And in this case, you don't even have to pick which 2 points to use because they're already picked for you. There are only 2 to choose from. And all you have to do is decide which one of them is point number 1. Like, I'm going to call the first one point number 1 because I'm maybe not that original. And then this point here, it's a minus 3, which got split up on the line. I'm going to call this point number 2. Or to maybe make it sound a little exotic, numero dos. Okay, so this is point numero dos. And I've got to figure out, well, if these are my 2 points, then I've got to figure out the 4 here is my x1, the 2 is my y1, the 2 here is my x2, and the minus 3, which is trying to hide behind the corner here, is my y2. And I'm going to plug those into my little formula here. I'm going to first put an equal sign to show that I'm just doing the same thing over again. On the top, like I said, I have y2, which is minus 3, minus y1, which is 2. And then on the bottom, I have x2, which is 2, minus x1, which is 4. And again, I just have to put a little fraction line in there just to make sure everybody knows what I'm doing. Okay, and then I got to do a little calculation here. Minus 3 minus 2. I'm sure you're all shouting at your screens because you know what that is. Minus 3 minus 2 is minus 5. And that's my number on top. And then 2 minus 4 will give me minus dos. Oh, you're learning Spanish in math class. Listen to this. And then I got to put a little fraction line in here to make sure I know what I'm doing. So minus 5 over minus 2. Now, if you have a minus on the top and the bottom, you put that into your calculator and you say, calculator, what's minus 5 divided by minus 2? It'll tell you that it's actually a positive number because the negatives cancel out. So since they're going to end up canceling out anyway, you can actually get rid of them right now. You can turn this into 5 over 2. Or if you're wondering, 2.5 is also correct here. But rise over run is so helpful here that keeping it as a fraction is probably going to be better for you in the long run. All is to say, I have a slope now of 5 over 2. And remember that my equation always looks something like this, y equals ax plus b. So if I figured out that the slope is 5 over 2, that means that I've figured out that the a is actually 5 over 2. Okay, so now that I've figured out my slope, all I'm missing is my b, right? And I could graph it and try and figure it out that way, but that won't always work because I can't always trust that my ruler is absolutely perfect. So calculations will give me a clean answer when a ruler won't always do that. And if you were paying attention in class today, then you know that once I've got my slope figured out, I know that since both of these points are on the line I'm talking about, the line passes through those points, that means that if I were to plug in, let's say, 4 into x here, then when I have the right b, it'll end up that y will end up being 2. So I just got to figure out what the right b is that will make it true that 5 over 2 times 4 gives me 2 at the end. And the way you do that is you start off, you say, well, let me just replace these. Instead of having an x here, I'm going to replace that with an x coordinate. I could use either point here. I'm going to use this point, 4 and 2. So where the x was, instead of putting x, I'm going to put 4. And instead of the y just being a y, I'm going to say, well, when x is 4, y should come out the other side as being 2. Right? So I'm going to get rid of this y here, and in its space, I'm going to put this 2. So 2 is equal to 5 over 2 times 4 plus b. And now you see this is all the letters that I had at the start, the y, the a, the x. All I'm dealing with now is an equation where there's just b who's left to figure out what he is. So I got to do 5 over 2 times 4, and there's a few ways I could figure that out. I could do, this is 4 over 1, so 5 times 4 is 20, 2 times 1 is 2, 20 over 2 is 10. And let me write that in here. My next line would look like 2 is equal to 10 plus b. Right? Because 5 over 2 times 4 is just 10. And now if I want to find out what b is, I got to subtract 10 from both sides. Let me do that. Whatever I do to the left side, whatever I do to the right side is fine as long as I'm fair, as long as I do the exact same thing to the left side. So these two 10s knock each other out, and all I have left on this side will be b. If I do 2 minus 10, I have minus 8 is equal to b. So this is, again, some Sec 1 algebra for you there. Minus 8 equals b. Now, since I figured out that b is minus 8, and I know that a was 5 over 2, that's all the information I need to have to write my equation. I can write it out. Y equals 5, I'm going to put that over 2x plus negative 8. That's a very thick fraction line right there. Now, if you're wondering, you could also, instead of writing plus negative 8, you could just write y equals 5 over 2x minus 8. That's perfectly good. You could write this here as 2.5 because 5 over 2 is exactly 2.5. With fractions, I want you to be careful about avoiding inexact decimal equivalents. So if this were something like 5 over 7, you couldn't really write that without having to write a whole lot of digits. But 5 over 2 is exactly 2.5, so that's okay. But that's your answer right here. Y equals 5 over 2x plus negative 8.